since I just introduced you to the global variable, and we have a next chapter coming in, which is for which covers global and local variables. Okay. So, what are these global variables? Yeah. So, we just saw a function here. This is the code what we have in the discussing. So, what we have here, I'm using this z in the main function as well as in the add function. Apart from using, what's happening to this z is in add function, which is called here, I'm updating z. Okay. And once it comes to main function, I print it, it will take the updated value. So say I'll initialize it just for time t and to make it 10. And I'll have one more printf here before this. Okay. Let's compile. Sorry. Control S problem. Yeah. So what you're seeing here is I have a z here because what we know is function always starts from main. Execution starts from main. It will come here. It first print z. Now it will go to add. Z is updated. Since z is global variable, I am able to read a updated value here. That's 65. Okay. So this is what a global variable is. And this is a very good use of a global variable, right? So you want to update something here and to use a updated value or real-time value in calling function. So then what are local variables? These are local variables. Yeah. So int C and D. And even here, A and B are local variables. Though they are passed, but those are, you can access A only in this function, or the value of A only in this function. So can I have same variable name in two functions? This is possible. Okay. I can have A and B here. Still possible. And it will still work the same way. There is A here, then there is AB, there is AB. But since it is local to this function, we pass A and B here for it to work correctly. E is 40 locally. 40 is passed, 25 is passed. It will come here. This is just a identifier for this function. Yep. So you're still able to do the same thing. Let's see a few more cases where the local and the global variables can, you might have a confusion. Okay. So what I bring it back to C and D. C, D, C and D. Okay. So then what we have, we passed these two, and then there is a Z which is updated. Right? Now, what we do can be, instead of A and B, since the C is 40, D is 40, can I use C and D here? So what we just discussed is whatever is defined within these brackets, okay, these are called local. Here C is local. This is not local, okay. Only variable can be local. These are statements. Right? So if you have a confusion, if this is local, this is not local. This is just expression, function. Variables are local and global. Functions, I mean, those are static and external. That we'll see later. Then can we use this here? Since C is this, C is 40, D is 25. Can we use this? So if we do a code analysis, we can easily say okay, this is my local function. This is my function, and the local variable C. So, and this is not a global variable also. Then it will fail. Let's compile and see. Does it fail? Yes, it just failed. Undeclared. C is undeclared here because C is declared here. In the moment this comes out of this function, C is no more referenced by this, right? Because it's a local variable. C is local to mean. So this is the reason. I mean, I think this might have clarified your doubt why we cannot use this directly here if you had one. So this is what I wanted to explain with this example. So we'll go back to A and B. So similarly, okay, one more instance. Okay. Can I have I have one global variable here. Okay. And then I'll define one more variable with the same name as that of global z equal to 20. Okay. Then what do you think will happen? Does the build fail? Okay. See, when I am doing this, what I am trying to achieve here, or maybe say if I intentionally define z equal to int z, here it means the scope of z in this function is limited only to this. Yeah, is limited only to this. So if with that understanding, it is safe to say it will compile. It will compile. What does it mean? This is what it will print. Local variables will supersede the global variable. So local variables taking priority, correct? So if you think practically, say I have 20 functions, one global variable like z, and in one of the function I am doing this. So there my main intention is, I don't care if there is a global variable z or not. But for this function, you can use a local variable z, which will not break your build, and that z will work very well as any other local variable. Yeah, whatever we saw in the code example, the same I'm trying to define here, okay? Or explain it in the slide. Yeah, you can see what we have the braces. This is called scope. What? So C is in the scope of function 1. That's what we saw, right? We can have a same variable, local variable in two functions. Int C here, still possible. Yeah. And here, there is a differentiation, what we just saw. I have int C and then C. No error. C is equal to A plus. So, but what we just saw on our example is where the local variable supersedes the global. And we will see the life of a variable. I mean, scope of a variable, life of a variable. Okay. And we'll go back to the code. So, if we come out of this function, A and B are no more valid, then they are destroyed. The variables themselves are destroyed because these are local variables. Okay. Scope of local variable is only to the function. Whereas the global variable scope is throughout the file or throughout the program, provided they are externed correctly. Yeah. So this is what I meant by scope. Even if you exit main, the Z is still there. Okay. So then you might ask, can I print like this? I think when you go through the local variable explanation carefully, you might get this question. Can I do this? I think this will just not work because the statements won't execute unless those are in some function. Okay. Let's see what happens. So what we have here is, yeah, so it's not able to identify because it has to be in a function. So this is one more thing I wanted to explain you regarding the scope of a variable. Yeah, variables do get destroyed, but whereas this doesn't get destroyed.